Hey, it's time for some MASc.
Linear functions are straight lines. Sounds easy enough, but they're surprisingly useful and versatile to tell for students like you, and you'll be using lots of linear functions throughout your undergrad at Ottawa U. The major focus of grade 9 in the Ontario high school curriculum was these linear functions. You may have fond memories of y equals mx plus b. If you went to high school outside of Ontario, you may have learned about linear functions at a different time. But in general, most students learn the standard y equals mx plus b or y equals mx plus c format. Here at Ottawa U, the math professors will typically show you one of two ways to represent the equation of a straight line. The familiar y equals mx plus b, where m is the slope of the line and b is the y-intercept. This is often called slope-intercept form because of the two parameters m and b, which then define what the line looks like. A second form, which you may or may not have seen before, is called slope-point form. We'll take a look at this one in a moment. But for now, back to your friendly neighborhood y equals mx plus b. In this applet here, we can see a graph of the function y equals mx plus b. At the top are sliders where we can manipulate the two variables m, which is the slope, and b, which is the y-intercept. We start with a slope of 1 and a y-intercept of 0. Notice that this line intersects the y-axis at 0. This matches the y-intercept of 0. Also notice that for every increase in x by 1, the y value also increases by 1. That's the slope. Let's see what happens when we increase the slope of the line. An increase in slope makes the line steeper. We can also go the other way, decreasing the slope of the line, making it steep in the negative direction. Also notice that a slope of 0 makes the line flat. Now let's see what happens when we mess around with the y-intercept. Increasing b will move the line upwards. Notice that the slope isn't changing. I'm not toggling the slope slider. Only the y-intercept is being manipulated. Decreasing b will move the line down. Now that we've reviewed the basics, let's answer the most important question. What are you expected to know about linear functions coming into Mat 1300? There are two major things. 1. Given some equations of lines, you should have a general idea of what they look like graphically and be able to sketch them. For example, compare the two equations y equals x plus 4 and y equals 2x minus 5. Let's start out by drawing x and y axes. Pause here to try the example on your own. The first line intersects the y-axis at y equals 4. The second line does so at y equals minus 5. The first line has a slope of 1, while the second line has a slope of 2. This means that the second line is steeper than the first line. Both slopes are positive. Based on this information, we can make a rough sketch of the two lines. Note that profs will often tell you to sketch functions in this course. They are expecting you to label the x and y axes, but don't expect each individual x and y point to be labeled. You did that in high school, and you don't need to show that level of detail anymore. I'll repeat, an extreme level of detail is no longer required. Instead, labeling the important features is what is required. The expectations for sketching will be covered when you get to the curve sketching section of the course. Let's get back to our list. Number 2. Given 2 points, you should be able to determine the equation of the line that passes through them. For example, given the points 4, 7 and 6, 10, let's determine the equation of the line that passes through these 2 points. Pause here if you'd like to try the example on your own. First, we can determine the slope of the line m, which is the change in y divided by the change in x. The prof will likely write this in shorthand notation as delta y over delta x. The Doritos chip is the Greek letter delta, which means final value of that variable minus initial value of that variable. This works out to 3 over 2, or 1.5 for us. Next, we can determine the y-intercept. Choose your favorite point of the two provided. Either one will work. I'll show both calculations for you. As you can see in both cases, we get b equals 1. So the equation of the line that passes through these 2 points is y equals 3 over 2x plus 1. I mentioned earlier that there was another form for representing the equation of a line. Let's take a look at that now. Slope-point form is written as follows. If you look carefully, you'll see that it's a clever rearrangement of the equation for slope, with the delta x and delta y terms expanded. This makes it intuitive and easy to remember. Not only that, a lot of students will also find this version a lot easier to use in practice. Let's see why by doing an example with slope-point form. Given the 2 points 1, 3, and 4, 1, let's determine the equation of the line that passes through these 2 points. A pause here if you'd like to try the example on your own. First, we can determine the slope of the line m, just like we did before. This works out to negative 2/3. I strongly recommend leaving this value as a fraction and not rounding to something like negative 0.67 in this case, unless a rounded value is allowed by your professor. Next, choose your favorite point of the two again, and sub it into slope-point form. This is where this form shows its advantage. Rearrange and solve for y and you have your answer. You don't even need to explicitly solve for the y-intercept and then plug everything back in like you do with slope-intercept form. Instead, you've already got it. The answer is y equals negative 2/3 x plus 11 over 3. Done and done. Does the prof care which method you use? Nah, use your favorite.
Hey, it's Katrina from Prep 101. I really hope you enjoyed that primer. There's definitely more where that came from. Make sure to join the Facebook Study Hub for this course where you and your peers can communicate, ask questions about the course, and get access to free study aids. Use the link in the description box. I hope to see you at our prep sessions. I'll break down the course content for you step by step, show you how to solve actual exam questions, and maybe we'll get in a few laughs along the way. Many prep sessions for midterms are free. Yeah, free. Visit prep101.com for details. Thanks for watching. See you soon.